Okay, so we're just going to forget about PowerPoint and use this one, right? Just for him, finally, hopefully one final time. Day 3, midterm. Day 2, maybe some studying. Day 1, maybe some studying. And day 0 is the day of planning. At day 0, we're just going to assume that there's no utility for that day. There's no consumption utility for that day. So she can plan to study in day 1 and day 2, just day 1 or just day 2. The utility involved would be, if studying on both future dates, beta times delta times 10 minus 1 plus delta squared times 10 minus 1. If studying only on day 1 would involve only one period of study with 10 minus 2.4 utility on that day, plus delta squared 10, because there's no study on day 2. If studying only on the second date, then there will be no studying on day 1, so the utility is 10, discounted by delta, plus delta squared 10 minus 2.4. Now let's see which one is the best. So you have 0.7 times 0.9 times 9 plus 0.81 times 9. Right. The second case is 0.7 times 0.9 times 7.6 plus 0.81 times 10. And the final case is 0.7 times 0.9 times 10 plus 0.81 times 7.6. Right. Here's the part where it's probably easier to bring out a calculator and use it to calculate. So 0.81 times 9 plus 0.9 times 9 plus times 0.7, that's 10.7, that's 10.77. Okay. The next one, 0.81 times 10 plus 0.9 times 7.6 times 0.7, that's 10.46. And finally, 0.81 times 7.6 plus 0.9 times 10 times 0.7, that's 10. Did I do something wrong? It's lower than the first one. It's actually 0.61. Let me check. Make sure I did the calculation correctly. That seems weird. 0.7 times 0.81 plus 9. 0.81 times 9 plus it is. Oh yeah, okay, so okay. Okay, that's right. Okay, so the calculations are correct. So what do we have? The first option of studying on 2 days have the highest utility, followed by studying on the on the second day, followed by just studying on the first day, right? So clearly the most preferred would be studying on both days. So plan to study on both days. we use day 0 as the benchmark of what a time-consistent user would do. So we use day 0 as the benchmark because that's what the time-consistent user would do. She's going to plan to study in 2 days. That's the most efficient way of studying by spreading it out, and it gives the highest utility. The question is whether the plan will be followed through. We have 4 more minutes, so we can easily show whether that's true. At t equals to 1, let's see what happens. Once again, the choice is whether to actually start studying now, studying only today, and studying on both days. Now, today is already day 1, so it's no longer in the future. So studying today would give a utility of 10 minus 1. Tomorrow's is in the future, so beta times delta times 10 minus 1. If only studying today, that would be 10 minus 2.4 plus beta delta 10. And finally, studying only on day 2 would be 10 today plus beta delta 10 minus 2.4 in the future. All right. Once again, you can punch the calculator. Beta equals to 0.7. Delta equals to 0.9. So what do you have? You have 9 times 0.9 times 0.7 plus 9. That's 14.67 today for the first option. Then for the second option is 10 times 0.9 times 0.7 plus 7.6. That's worse, 13.9. And the last option, 7.6 times 0.9 times 0.7 plus 10 is 14.79. So what do we have here? Turns out studying only tomorrow on the second day, so studying only on second day becomes optimal according to this student's calculation on the first day. So there's a change of plan. Study only on day 2. Okay, so this illustrates the what we call time inconsistency. You plan to do one thing, you're doing another thing when it actually comes to execute the plan. And it all comes from the fact that the model builds in an assumption that today is special. So when you plan for the future versus future, no big deal. But when the future comes, it becomes today versus future, then you don't want to do things that are costly. Okay. So we're going to go more into this kind of numerical example next week, and you'll see that it gives a lot of interesting predictions, and how we also talk about how we could apply it to some financial applications.